This is question 31 from book number 1 based on the 2020 NEC, and this is electricaltime.com, where an appliance is rated 4,500 watts and is considered as a single non-motor operated appliance, 240 volts, single phase, and where the overcurrent protection is not marked on the nameplate. What is the max size overcurrent protection breaker? And the answer to this question, just want to take 30 seconds to let you know what we do here at electricaltime.com. We do online electrical classes from the comfort of your home. And then we also have this free service. So if you click on the subscribe for free NEC questions, Monday through Friday, you'll get an NEC code question and an answer sent to your email. All right, so back to our video is going to be C. That is going to be 30 amps to pole. All right, so when you're looking at this question, first question you're going to ask yourself is, what article are we talking about here? And I see appliance. So I'm automatically thinking that's going to be article 422 for appliances. But let's hold off for a second. When I see watts and I see volts, I'm also thinking maybe I should be calculating amps at this time. And here's what I do when I'm taking an exam and I see watts and volts and amps and resistance and ohms. So what I do is I write real quick, I write Ohm's law over here, and then I write pi. All right, so I know that I've got 4,500 watts, so I know that the P in pi, that's going to be 4,500 watts, and I got 240 volts, and I know that the E in pi is going to be for the volts, but I also know the E in Ohm's law is also going to be 240 volts. So now I know I have enough information to solve for I, which is amps in pi. So here I got I is equal to P divided by E, and I is going to equal 4,500 watts divided by 240 volts. And if I do my math correctly, I think that's 18.75 amps. And let me just double check that on the calculator. If you can double check on your calculator, that would be great. So 4,500 divided by 240 is 18.75 amps. And let me just fix that 5 a little bit so it's a little bit neater. Okay, and there we go. All right, so let's just stop here for a second. Let's do a little bit of electrical theory, if that's okay with you. And so now I know I know my amps. So now what I can do is I say, well, okay, I know my I here in pi, and I know my I here in Ohm's law. Now I can actually calculate the resistance of this. And this is the beauty of writing down Ohm's law and pi, is that very quickly you can see what's missing, and then you can start solving the problem instead of looking up at the ceiling and wondering when the answer is going to come to you. Just write these two things down, and they might help you later in the question. All right, so let's take a look at what we got in our textbook. So we are talking about Article 422, appliances. That's within Chapter 4, equipment for general use, and that's in Part 2, installation. That's 422.11, overcurrent protection. Then we look at 422.11e, single non-motor operated appliance, and then we find 422.11e3 not to exceed 150%. So let's read that together in our code book, and we're going to read 422.11e3, and it says here, not exceed 150% of the appliance rated current if the overcurrent protection rating is not marked and the appliance is rated over 13.3 amps. Where 150% of the appliance rating does not correspond to a standard overcurrent device ampere rating, the next higher standard rating shall be permitted. All right, so are we over 13.3 amps? Yes, we came out to 18.75 amps. So we're good so far. So let's see what we got here in our textbook. So we're going to look at the pi formula like that we just did. All right, so let's do it again. So P is equal to I times E, where P is equal to watts, I is equal to amps, E is equal to volts. So let's rewrite the pi formula and solve for amps. I is equal to P divided by E. I is equal to 4,500 watts divided by 240 volts. I is equal to 18.75 amps. So the next step here, 422.11E3 says that if the overcurrent protection is not marked on the appliance and the appliance is rated more than 13.3 amps, then we can use a max of 150% of the rated current of the appliance to calculate the overcurrent protection. So here's where we go now. We got the 18.75 amps times 150% is equal to 28.125 amps, where 150% amps does not correspond to a standard size breaker. We can use the next higher standard size breaker. And what is the standard size breakers out there? And that is going to be table 240.6a. And it's called the standard ampere rating for fuses and inverse time circuit breakers. Also, if you don't have this already, go check out the NFPA link. You can find that at the website for the NFPA, and that's nfpa.org. It's having the code book on your phone. It's really a wonderful value. I highly recommend that everybody get it. All right, so when we did the math, let's go back and take a look real quick at that math. We came out with 28.125 amps, this number over here. So now we need to find a breaker that's going to be good for that. Now, do they make a breaker that's 28.125 amps? Is that a standard size breaker that you can find? No, of course not. So what we do is we look at this table and, we see that 25 amps is going to be too small, so that's no good. We're not going to use that one. And we're going to pick 30. So 30 amps is a standard size breaker. And that's going to be the answer. All right, so let's go back up into our textbook and continue where we left off. So we see in table 240.6a for the standard size breakers, since 28.125 amps is not a standard size breaker, the next size up is 30 amps, and that is the answer. So again, the answer is C, and that's going to be 30 amps, and that is going to be a 2-pole breaker, and that's the answer.